Hi everyone, Sertalp here. So this will be our final video on optimization for FPL using Microsoft Excel video series. In this final episode, we will consider a multi-period full FPL problem from start to finish. So we will be using what we have learned in the first two videos, and we will be adding some additional stuff like using your own squad as the initial input. And also we will consider how to make transfers, how to buy and sell players, and make sure that they always stay in our budget. So for this purpose, we will download again FPL review data, but I should remind you, you can use any data you want if you have these predictions from other sources, or maybe you have your own model for predictions. So these methods that I will mention here is still applicable to those. So the problem we are defining here is actually can be used with any kind of data. With this in mind, let's go to fplreview.com and download the data very quickly. So for this purpose, I will be using last year's winner, Joshua Bull's team, and this is the team ID of that team. I will be using a real team in this episode because we will consider buy and sell values. Okay, and here I will click all players. After it changes, click download data. So now we have the data. So we can minimize this window. We can open a new empty Excel sheet. And we can do the same. From text CSV, I will use FPL review 1 is the file we just downloaded. I will choose Unicode so that I can see player names correctly displayed. I will click load. So we have all these predictions, but it is in table format, so I will just copy these into a new sheet using only values, and I will get rid of this, the first one, and I will close here. Okay, so now we are ready, and remember in the last video we added a new column here called position numeric, and it was based on switch, and we were using B2. If it is goalkeeper, it's 1. If it is a defender, it is type 2, midfielder 3, and forward 4. So we are doing this for sorting purposes later, so that our team will be displayed correctly. So now I will need all the fields here. So I will need buy value, sell value, team. Obviously, I will use these points values too. So we won't be using expected minutes here in this video, but it is possible to include these into your decision making somehow. So if you can make it part of your objective function, or maybe your constraint, so maybe you can give a constraint saying that expected minutes of each player cannot be less than this value. So here I will just sort this very quickly. Based on expected points for the next week, and we already see good selections here. So in single period FPL problem, remember we had binary selections, we were choosing a single captain, we were trying to stay within budget, we had a squad count, and we had lower and upper bounds for our lineup numbers, and we also had a team limit, like 3 players per team limit. And we were also checking whether a player appears in lineup or bench, not both at the same time. We also saw 2 optional constraints about forcing a team formation and also forcing a custom team limit. And we also talked about OpenSolver options, specifically about tolerance, maximum time, and we talked about solver engines and network enabled optimization system. So in multi-period FPL problem, we will be using all these single period FPL constraints, but this time we will be adding them a new dimension. So we will be adding the period, so the game week data into it. So we will be using all these basic constraints that we have built in the previous one, And plus we will have a buy-sell squad relation. So if you buy a player, they should appear in your squad. If you sell a player, they shouldn't appear in your squad. As an extra, we will also consider how much money we have in the bank per period, so we can make sure that all the transfers we are making are within in our budget. And we will also talk about a rather advanced topic of free transfers. Free transfer logic in FPL is a little bit interesting. So you have a certain number of free transfers each week, and based on whether you use them or not, you end up with a different number of free transfers the following period. So unfortunately, this logic is not very simple. It is not linear, but we can write it as a linear constraint, and we will talk about how to do it, and it will require kind of a trick from our part. When we are modeling the multi-period FPL problem for the first time, we will put a simple bound on how many transfers are allowed, and then we will talk about why free transfer logic is a little bit more complicated than all the other constraints we have been writing, and how to write it. Let me go back to the Excel sheet, and as you see, I already have my fields here. In here I will make sure everything is centered first, and the first field we will have, just like we did in the previous videos, is lineup. But in this case I will be using +1, +2, +3 based on how many periods ahead we are planning. And I'm using +1 instead of maybe game week 24, because then you can change this data and not get confused about whether you are using an old game week or not. So I will be using +1 for the next week, meaning game week 24 here, +2 for 25, and +3 for 26, so that you can replace this data and we'll still have a working model, so you can reuse what we are building here. So this will be obviously a variable, but I will just put 0 everywhere and line up +2, and also even line up +3. So these are all zeros, and I will choose these and I will just color them green as we were doing in the previous videos. And the second field we will need is bench +1. I'm putting same type of variables together because when we are extending the formulation, it will be simpler for us to do it. I will just color them green as well, and I will use captain +1, and again the same thing. So we will have a captain every week, and we will make sure that this number is equal to 1 and coming from a player who is currently playing. So different from the first videos, we will have new fields. The first one is buy +1. Buy +1 is simple to understand whether we are buying a player or not. Again, buy +2 and buy. Actually, let me do this for all of them. So we will also have sell +1, sell +2, sell +3, and double click so that we have all zeros everywhere. So buying and selling players are also binary variables. So this is something that optimization should decide. So I will color them green as well. And we will talk about how many transfers we can make separately, but for the main decisions, these are all the decisions you need to do. And here I will put something I call squad +0, meaning this will be an input parameter, so I will color them yellow. So this will be your initial squad, so whatever players you have currently in your team just before this game week starts. So next I will have what I call squad +1, so these will be your squads for the next week, and then the following week, and then the following week. And these values this time is calculated a little bit different than what we did in past. So in the previous video, remember, squad was summation of lineup and bench. In here though, this will be based on whether I have a player from like currently, or if I bought this player this period, or minus if I sold this player. So basically this is the previous squad value plus whether I have bought this player or not minus whether I have sold this player or not. And we will make sure that these values will be always between 0 and 1. So they will, because a player can be either your player or not. So as you see, we are using a formulation, right? So this is not something that we will decide. This will be an outcome. So this, I will color them blue for this purpose. So if I extend this formulation, for example, for squad 3, you can see that I am using squad 2, squad plus 2, plus whether I bought this player this period, whether I sold them. So this is satisfied, and we can actually try this by giving a value of, for example, for Sterling. If you have him initially, you see that these values are 1 now. So suppose I am planning to sell him in the second week, then these values will be 0 for the rest. Okay, let's clear everything. So we have our decision variables, we have our initial input, and then our metrics for the squad. So I will be using some extra columns here just to make sure that we have a player appearing in lineup or bench only once. So this will be lineup or bench plus 1, similarly for others. And this will be the sum of lineup plus bench for that period. I will extend this, copy this, and color it blue. And finally, this is for actually preparing the final table. This will basically show me whether I should display this variable or not, display this player or not, and this will be based on whether the player is in my squad or if I sold the player. So this is not something that you need for the optimization. This is for actually displaying the final table. So not to confuse us for now, I will just hide these columns. So the next thing we are gonna do is we are gonna add positions as we did before. So we will say positions, and remember we have 4 different player types, and we will put our squad limits. It should be 2, 5, 5, and 3. And in this case, we will see how many of this player type we have in our squad. And remember, we need to satisfy these numbers for all the position types. So I will say squad picked plus 1, and then maybe I can, just to save some space, I will just call this squad picked plus 1, and then we will have for all the 3 periods. And you could remember, but what we were doing is we were using some product, and we were using this minus minus before the first array, which was converting this array to a 0-1 array using the condition. So in this case, we are checking if the position here from B2 to all the way to here is equal to this position ladder. In my case, it's G. So if it is a goalkeeper, it will take value 1, otherwise it will take value 0. And I will multiply this with whether I have this player in my squad all the way to here. Okay. Just to test this, suppose I have a goalkeeper. Let's see, Pop is the highest goalkeeper in the set, so I will assume that I am starting with him, and then as you see, I have 1 here. So it seems to be working. So one thing I need to do is, so remember this B was my position array here, so I don't want this position array to be changed when I'm extending the formula to the right. So I will put $signs in front of B so that B will stay as B when I copy it. And also from 2 to 669, so this is fixed too, so this is how many players I have. And in here I don't want AM to be changing, but I want 2 to be changed because when I'm copying formula towards the bottom, this number will change and then we will get others. So again, similarly here, okay, let me fix this actually. So when I'm extending formula to the right, I want, instead of squad this +1, I want to use squad +2. So I will just, I won't put any dollar signs here, but I will put dollar signs to this. So I will copy this formula here and then all the way here. And when I press F2, I can see the formula, and as you see, I'm checking if this is a goalkeeper of the type is goalkeeper using this positions ladders, and then I'm multiplying with this array over here, which shows whether that particular player is in my squad or not. So I know these squad limits are parameters, so these are defined by the problem itself. And these are my metrics, outcomes, how many of that particular type I have in my squad. And so when we are writing the constraint, you will see that we will force this one to be equal to this one, as we did in the previous video. And this is for lineup. This is lower bound for the lineup, and this is upper bound for the lineup. And remember, it was 1 for goalkeeper, 3 for defenders, 2 for midfielders, and 1 for forwards. And upper bounds are similar to my squad limit except the goalkeeper. And this is how many of lineup picked +1, and then all the way to 3. Let's scale these again. And then I can actually use the same formula here with a difference. Instead of this, instead of checking whether the squad or not, I want to check whether that particular player is in my lineup or not. And then I can extend the formula. I can check it. As you see, I'm checking lineup 3 here. Again, it's starting from the first and goes all the way to bottom. And these are problem parameters. So we have enough component for the positions. So now what I'm gonna do is I'm gonna come here and use a unique list of these teams, and I will here I will just choose this column. I will under data I will click advanced filter, and it will just complain about something. And when I click OK, the first row will be the tag, and I will say copy to another location, and I will mark here this cell, and then I will say unique records only. And as you see now, I have a list of all the teams. Let's actually sort this very quickly from A to Z, so it will look nicer. And now, actually I can even move this thing a little bit so that I will have some space here. So this is how many of this player I have. I will count how many players in my squad of this particular team, and I will use the same thing. Actually, I will use some product again, minus minus, and then in this case though I will use all these teams here, and I will check if the team name is equal to this cell here. Currently it's behind the formula, but so, and I will say multiply this with whether that particular team member is in my squad or not. And again, what I need to do is I need to put dollar signs to F, and in here I will extend the formula to the right, so I will be using a dollar sign to here, and for here I will be putting dollar signs only to numbers. And then I can copy here and then copy here, and I can check actually the last team here. So as you see, it's using squad 3, and then it's using the team names, and then everything looks good. So I will color them blue because these are the outcomes of my decisions. So I will be forcing these values to be between 0 and 3 for all of them. And so the one thing we need to do is we need to count how many captains we have. So this will be the captain count +1 all the way to 3. And captain count is easy. We just need to take the sum of actually let me do with the formula S2 to 669, and similarly for all of these, and this will be the sum of captain plus 3. And remember, so these needs to be exactly equal to 1. And next is my in the bank value. So in the bank, like how much money I have in the bank will start with your own input, and I will just color, I will color it yellow so that we can understand this will be in the bank plus 0. So this will be your initial amount. So you need to be filling this by checking how much budget you have. So and then this will be in the bank plus 1. Let me rescale them again to give some more space. And as you see here, so suppose my initial budget is 0.5. I just randomly using 0.5. And here what I'm gonna be doing is my in the bank amount next round should be this amount plus some product. And here in some product, first of all, I will have more budget when I sell players, right? So what I'm gonna be doing is I will multiply all these sell values, okay, with, and I will come all the way here with these values. And you will see how it works. Like currently it's 0.5 because my initial budget was 0.5, right? So suppose, actually let me also come to view and then freeze these columns so that we can always see which player we are talking about. Suppose I have Sterling in my squad initially, okay, and I sold him in the second round, or let's make it first round, okay. So this sell value here, 11.6, will be reflected in my in the bank budget here, and it will become 12.1 as you see. And however, we are also buying new players, right? So this will be minus some product. So we will do the same thing for this time for buy values, this. And when we are buying players, instead of sell value, we need to be using this buy value column here. And I will be using those. And as you see now, and suppose I didn't have Gündoğan to begin with, and when I buy, you will see that I am earning this much money by selling Sterling, but I am losing this much money by buying Gündoğan, and then it will be reflected. And let me make these 0 again. And so this in the bank formulation. So let's see. I don't want my these E values to move, and also same for D, but others can move. So I will just extend the formula here, and we can just check if we are doing the correct thing. So what I am doing is I am using AP. So this previous rounds in the bank value plus my whether I have sold this player times the sell value minus whether I have purchased a particular player times the buy value. So the formula looks correct. I will just color them again blue. Okay, now next is actually our objective. Oh, just before going for the objective, we need to have the lineup count. So lineup count should be always equal to 1, right? So the lineup count should always be equal to 11. So I will just take sum of all the lineup values for the first period. It is from here to here. And similarly for all three. So these values will be forced to be exactly equal to 11. And the next thing is how many transfers we are making, transfer count. So I talked about this very briefly. What we will be doing is I will just name them transfer count 1 to 3, and this will be simply sum of all the buy values here. So you don't need to consider sell at the same time. And oops, I think I made a mistake in the formula. You don't need to consider sell at this point, because how many players we are buying, that many players we need to sell to satisfy these exact squad numbers. So we can be fine just by checking how many players we are buying, and then I will extend this formula, and then as you see I have everything here. So initially we will be using these transfer counts in our calculation, in our constraint. So we will be forcing how many transfers we can make. That's why I'm putting them, I'm just coloring them blue, their background. I need to have a objective column, and then I will just use here. So this is my total objective. So this will be the sum of all the expected values. So this is my expected points at the end, and I will put XP plus 1, and then for all these 3 weeks we will be counting how much expected points we are accumulating. So again, this will be the sum product of whether I have a player in my lineup all the way to here. Come on. So this is a little bit tricky, but because the points columns are not next to each other, but I will be choosing them one by one. So this, I will be multiplying my lineup with the expected points coming from the very next round, and then I will be copying this formula all the way here, and then when I choose the second round, you will see that this column needs to be moved here, and then for the third one I need to use the third week. So now this is correct, and I can just color them blue, and then the total objective is essentially sum of all these 3 values, right? So, and remember I was coloring the objective with a different color so we can understand. So this is the objective, this is the final expected points that we will try to maximize. One thing here is, notice that we haven't used bench values or captain. That's what we are gonna add next. So what we will do is we will add a weight parameter here. So let me call this bench weight, and I will start with 10%, like what we were doing in the previous video. And in here I will say, again, let me start with the weight, and then we know that this should be a fixed column all the way around, multiply with some product and this time I will check whether that particular player is in my bench or not. And then I need to also be using expected points again. And in here it's this value, so I will just copy it here too. Plus, the same thing will go for the captain, but the captain's multiplier is 1 because the captain plays like an extra player. So this is from S2 to S. And then again, I'm copying all the expected points here, and let's see. I think this is seems to be working fine. So for the second I will do the same. I will multiply and for the second, actually let me delete these and then copy this formula again, and this time hopefully this will be the last time we are doing this, but oops, let me zoom out a little bit so it will be easier to manage. And then here I won't be using this, I will be using points, and this looks correct. And for this one, see, lineup 3, bench 3, captain 3, and I need to be using the points from the third game week. And we are all okay. We are all ready now. So what I am gonna do is I'm gonna limit how many transfers we will have. So this will be the transfer limit, and I will limit this value, but I think we are ready to write the problem. And then I will just rescale everything, and then I will come click data, and then under model I will click model, and then I have an empty model now. What I will do is I will choose an objective cell, I will click maximize here, and then I will click my objective. Okay, now that we have our objective, the next thing we are going to do is we are going to choose our variable cells, and then here it comes all the way from here. I'm choosing all these green cells all the way to bottom, as you see, and then I will just click save, and then you can see that they are already colored. And under model I will be copying these names here, and I will be saying these are binary values, and then when I save, as you see, it will put the binary flag here, so the optimization knows that these values are binary now. So the next thing we are gonna do is we are gonna say, so we want these squad values to be either 0 or 1. Actually, it goes for all these fields until here, so I will be just choosing these and then all the way to bottom, and then I will be saying these values, oops, I think I just copied it twice, and I will say these are less than or greater than or equal to 0. See, I already added it. And then at the new constraint I will just copy the same name, and then I will say this should be less than or equal to 1. So optimization will know that a player can only appear in lineup or bench, and same will go for the squad. So you cannot buy the player you already own and then increase the multiplier, so it will be bounded. And then the next thing that I'm gonna have is my squad levels. So I will say this values over here should be exactly equal to this squad limits. I will add it. Similarly for the second game week. And then the third game week. For the lineup, we will do the same. You can just fast forward this part, but basically for lineup counts, I will say these should be greater than or equal to these minimums. And I will add this. I will choose second game week, and then say this is greater than or equal to lower bounds. And then the third one, I will do the same. So the only thing that we need to be care about the upper bound is actually the goalkeeper, because these other upper bounds will be provided by the squad itself. So I won't be considering those. I will just simply say all these goalkeepers here, they should be less than or equal to 1, exactly 1, so that we will be okay. We don't need to do the upper bound for all of those. And the next thing is I will say all these team counts, like player counts for each team, they should be less than or equal to 3. So I can have at most 3 players for every round. And the next thing is I want to have exactly 1 captain every week. And let's see, the next thing is my in the bank values can never be less than 0. And my lineup count is next. These lineup counts, how many players I have in my lineup, should be always equal to 1 exactly. And so this is the constraint that we will be changing later, but I will say all these transfer counts should be less than or equal to this value here, and current it's 1. And let's see. Let me see if we are missing anything, but yeah, looks like that's all. So if we try to solve this problem, it will generate an error. it will say the problem is infeasible because we cannot have only one transfer and have enough players to play in the second round without giving the initial values. So, and I will come here. I already prepared it, but if you go to FPL Optimize, you can find the squad like this. So you can come to the live game week and then type the team name. So this could be your own team name. And then when I do this, if I go to edit team, then I will get a list of all the players in the squad. So I can just copy this and then just go over them. Similarly, if you go to fantasy.premierleague.com, and if in this URL you can feed the team ID here and then the game week here, and then you can see the teams last week's lineup and the bench, and also you can see them as a list. I will be copying these values from here because it will be easier for me to just check them. And then I will come here. I will just copy them over here so that I can find all those players. So here what I'm gonna do is under here I will type a formula. I will say if, and then I will count if. I will say just check these squad values, and if they are equal to this here, then this will count how many times there's an occurrence, and this will take value 0 or 1 based on whether that player's name appears here or not. If it does, then this value should be 1, or otherwise it should be 0. I think, yeah. And I need to make sure that these cells, they're not moving when I copy formula down below. When I do this, you might have noticed that I have 16 players now. What I'm gonna do is I'm gonna sort this by squad 0, so we can see which player we have as an extra. I think there are 2 Fernandez, and I want this to be exactly equal to 0. So, and then I will just copy all of these and then paste it, just the values, so that it will be easier for me to manage later. So as you see, I'm starting with a valid squad at the beginning, so I don't have a valid lineup yet, but at least optimization knows that I will have enough players for every round, and you can see that all these team bounds, they are being satisfied too. So we are ready to solve this problem. What I'm gonna do is I will come here, click solve, and then based on the solution, we will see if we are missing any constraints or not. One constraint that I am missing right now that I remembered is choosing this captain among eligible players. So I will say all these captains here, so this is a range. As you see, I'm choosing all 3 columns. These should be less than or equal to, and I will choose lineup, so that if lineup value is 0, it will mean that you cannot choose that player for as your captain. I will click save model, and then you will see that captain and lineup is already marked because they are related to each other. I think I'm ready. Just before solving the problem, I actually tried to give some lineup and bench values initially using the initial squad, and notice that we have an error here. So I will come here. You see that these lineup counts here, I think they should be all the way down here. I typed this as equal to 1, but this should be equal to 11 instead. So I will just save it, and then now see that it's showing 11 equal to all these. So this initial solution is actually based on the highest XP players for the very next round. So if I don't change anything, so this is a valid solution, but I will be coming here, solve, and then clicking solve, and see my current objective is 181. And as you see, we have 10,000 variables here, and then setting up the problem is taking even longer than what we have done before. So this will take just a little bit more, but once the problem is written, it will go faster. Writing the problem is taking longer because this problem needs to be written into a file format that Solver can understand. As far as I know, OpenSolver is using LP file format, which is a more explicit type, and it will take a little bit. Okay, so we solved the problem. So one thing we have missed here is the squad values, and then either having players on lineup or bench should be equal to each other. And as you see, it's currently not. And then optimization ended up putting everyone to bench. There are two ways to handle this problem. Either we can put a bound on how many bench players we have, so we can put a bench count, or we can simply say that all these squad values should be equal to this, because this essentially counts how many players I have in either in my lineup or bench. That's what I'm gonna do. I will just say these squad values here should be equal to, and now I will choose this, and I will choose all these fields, and I will, before I add this constraint, yes, looks correct. I will save model, and then you see I have some green borders around them now. I will resolve the problem. Hopefully this will go faster. Okay, so we have solved the problem, and as you see, our objective is 207 now. So there's the expected points that we are accumulating over 3 weeks, and as you see, we have individual weeks expected points. So our next week expected point is actually larger, because we have double games for some of the teams. But anyway, so as you see, we use all of our transfer counts, and what I'm gonna do is, as you see, I have some values 1, 0 all over the place. So what I'm gonna do is I'm gonna open a new sheet so that we can summarize these results easier. And here I'm going to just create a table. So this will be game week plus 1, 2, and 3. And then just let's make sure that everything is aligned center. And here, what I will do is I will also insert a new row. So I will insert all these values for now, because I will be using their numeric value. So actually, let me do this. So insert copied cells. And then, so this will go from 1 to all the way to 37. So I will be using some of these metrics to actually filter and sort. That's why I was bringing them here. So I will just use filter, and as my filter, I will use all the values here. Everything here will go into my filter. And as a filter, so for the first game week, I'm just looking whether they should be displayed or not. That's why I'm gonna use this column, and then I will go all the way to down, and I will put a greater sign and then 0, and then I will close this. When I do it, you will see that it is only choosing the players that will appear in my lineup or bench, or the players that I have sold. So just to give some more space, actually I will just delete these for now. And then let's see, so this is my game week 1, but I will put some extra space because we can have more than one player selling when we change the model. And also, as you see, I see my lineup here, and I also see my bench players for this game week, and this player is being sold, as you can see here, sell +1. So what I will be doing is I will be copying this formula down below, and then I will change this filter, because instead of display value +1, I will be using display value +2. Okay, so I copied everything, and what I will be doing is I will be sorting them, and I will just fast forward this part too. But essentially what I'm using is I'm using sort, and then this array comes as an input, and then I need to give an index of which column that I need to sort these values with, and I would like to sort this especially with the lineup. First of all, I want lineup players to appear first, and then I will apply another sort. So this will be a nested sort inside. Instead of 13, I will be sorting with the bench value. Again, I'm putting -1 so that the higher values will appear first. Another sort, nested sort, is that I need to sort them with the position number. So I want goalkeeper to appear first. So remember, position number was our first one, and after everything is same, I can sort these by their expected points, which is column 8 in this case, comma -1. And as you see now that I have a sorted list with my lineup players appearing first, and then my bench players, as you see, my bench players are appearing second, and then finally I have the only player that I'm selling this round. So I will again, I will just copy and paste this formula down here and here, and I actually need to change this formula so that I will be using display value 2, and in here I will just use a k so that it will display period 3. So I don't need these, I will just hide them. And for this part, I don't really need to have these, so I will just color them white so they will disappear, and I will just choose whichever columns are not being used for that particular period. Okay, so I think we are ready. So let's see what's happening here. So I will also just adjust sizes. But in the first period, we are selling Son, and who are we buying? We are buying Rapina to put him to bench. Strange, but okay. And then I am captaining Gündoğan the first round. And then in the second one, I think I need to just use the correct sort values here, but remember 13 was lineup +1, so I need to use 14 here, and then 17 here, and then instead of 8 I need to be using 10, which is the expected points for the second period. Okay, now we have the correct order. And similarly for this one, instead of 13 I will use 15, instead of 16 this will be 18, and instead of 8 I will be using 12 so that we can sort everything. Okay, the second period, let's see, I am selling Brewster to buy Inks, and I'm using him in my starting lineup, and in here Gündoğan is bench, surprisingly. And finally in the third period I'm selling Fernandez to buy Son back. So this is a benefit of using this kind of an optimization model. You can sell and buy players back. So the optimization is in total control of who to buy and sell. I will hide. So this is basically it. So this will show you what are the moves for the next 3 periods. One thing that we are missing right now is actually transfer counts, because as you have noticed, we are forcing 1 transfer per round. We are limiting it with 1. We can make this 2, and then we can get a different solution, but there is something we need to consider. So I will now talk about the free transfer logic. So we need to be able to model in a way that so the penalized transfers will get -4 point hit. And so the logic is a little bit interesting, so I will talk about it. In here, you see on the left, I have period 1 free transfers, and then I have transfers made, and then I have the resulting free transfers for the next round. So if you are starting with only 1, and then if you are not using your free transfer, then you will get 2 the second round. If you start with 1, and then if you transfer at least 1 players, and this could be more than 1, like you can transfer 4 players and then 3 of them will be penalized, but in total then you will get only a single free transfer next week, because as you know, free transfers are always between 1 and 2. Either you have 1 free transfer or 2, and the only way to get 2 is if you don't spend all of your free transfers. And in the case of when you have 2 free transfers, then if you're not using any of them, you will get 2 the following round. And if you have 2 this round, and then if you use 1, then you still have some free transfers that you haven't used, so it will be 2 at the end. And if you have 2 right now, and then if you use 2 or more, then you are losing all your free transfers, and then you will end up with 1 the next round. So if you write this mathematically, this is the formula. I know this could be a little bit scary, but let's walk over this together. F1 is my free transfer in the first period. T is number of transfers made. So whatever free transfer is, I'm taking minus transfers and adding +1. Because this +1 is coming from because of the accumulation. So you get a new free transfer every round. So here, for example, let's go over the first row. I have 1 for the free transfer right now. I haven't used anything, and then the second round I am gaining 1 more, so this value becomes 2. So here I'm saying maximum of either 1 or 2, and obviously it is 2, so this maximum formula gives me 2, and then the other formula says minimum of 2 and 2, and then finally F2 takes value 2 because of it. As you see, F1 minus T is 0, or even it could be even negative here. Like if you have transferred 5 people, then this will be -4 +1 -3, and then I'm getting maximum 1 or -3. So the role of this maximum is to make sure that this value never drops below 1, and then that's what I get. I get 1, and then the purpose of minimum here is to make sure that this never exceeds 2, because if you have 2 free transfers, if you haven't used any of them, this will be 2 minus 0 plus 1, 3, and then I'm getting maximum, so this becomes minimum of 3 or 2, and then F2 will get value 2 because of it. So the maximum and minimum is just making sure that I never exceed 2 free transfers and never fall below 1 free transfer. So, but as you may have noticed, or you could have an idea, but this min, max, and then this formula is not actually linear, and this will cause problems, because so far we were just dealing with basic mathematical operations, right? We were just summing values, we were multiplying them, but we were never using like minimum of these to maximum of these to kind of relation. So if we try to formulate this in Excel, and then if we try to use OpenSolver, it will cause problems because this is not a linear one. And remember, we downloaded the linear version of OpenSolver. You can use this kind of a relation and then use advanced OpenSolver version. That version is free too, by the way. But first of all, solving that problem will take longer, and most importantly, when you solve a nonlinear problem that way, you cannot be sure if it is the optimal solution, because nonlinear optimization is totally different. So our best chance here is if we can linearize this, if we can write a linear equivalent of this formula, then we are good. So main idea is to introduce an artificial binary variable, sometimes called an auxiliary variable, and this variable should be equal to 1 if and only if there is excess, meaning unused free transfers, otherwise 0. So we should write a linear formula in a way that we will have a binary variable which will be forced to be equal to 1, exactly 1, if I have unused free transfers and otherwise 0. And this is that formula actually. And remember, F1 is my free transfers from this first period, and T is number of transfers I'm making this period, and A is my artificial binary variable. And this may not be visible at the beginning, but let's go over all the cases. So if I have 1 for F1, and if I'm not using any transfers, then F1 minus T is equal to 1. And this constraint here will turn into 1 less than or equal to 2 times A. And I know that A can either be 0 or 1. And in this case, what we are writing is 1 less than or equal to 2 times A. And in this case, A cannot take value 0. It is forced to be 1. Okay? And similarly, if F1 is 1 and then T is more than 1, then this value will be 0 or less, and then A could take either value 0 or 1. But we need to be sure that if I don't have any unused free transfers, it should be equal to 0, right? So what's gonna happen is this part will take value 0 or less, or a negative value, and I'm saying this is greater than or equal to A plus minus 14 times 1 minus A. This minus 14 is coming from the theoretically, I mean, you can only have at most 15 transfers in a week. So like you can sell every player in your squad and buy totally fresh new squad. And this could be 15 at most. And F1's smallest value is 1. So 1 minus 15 is giving you minus 14. And so this here will be a value between 0 and minus 14. And this will enforce that A cannot get value 1, because if A becomes 1, then notice 1 minus A will turn into 0, and 0 times minus 14 will cancel this part. That's why when we have 2 transfers, and then if we haven't used any, or if we use just only 1, this part will make A to be equal to 1. And if we have 1 free transfer and used it, or if we have 2 free transfers and used them all, then this part will turn into a 0 or a negative number, which will force A to take value 0. So why we have done this? Because if we can have this kind of a binary variable, then simply by taking plus 1, you will see that I am actually getting exactly the free transfers I need to have in this following round. So this is how we are gonna model a free transfer. So I should mention this part is, I mean, up to you. This is kind of a trick we are using for the optimization. You don't need to be using this. You can just play with the limits. So you can put limits for the transfers you are making for every round and play with them. But using this will help us, because we can then count how many free transfers we are using, and then we can also put a penalty for the penalized transfers, because currently our optimal model is not allowing us to take a transfer hit. What I'm gonna do is I'm gonna get rid of this actually constraint here. So this is the constraint that includes 39. So I will go data, and under model I will find that constraint. I think it's this one. Yes, this one. I will select delete constraint, and this transfer counts, I will just delete them here, and I will also make no fill, and then we can actually move these columns here so that we have some little bit space. And I will save this with final with transfer hit. So remember, we will have an auxiliary variable, so we are adding a new variable besides these. So I will call them a plus 1, 2, and 3. Okay, these are my basically auxiliary variable, and I will have my free hit plus free transfer plus 0. So this will be my initial number of free transfers, and I will have all the way to 3. And and I will have how many transfers I'm making. So this will be the transfer count plus 1, 2, 3. And finally here I will get my f minus t, and this will be for the first period. Oops. So this is just my formula for, and I will take this free transfers minus number of transfers I'm making this round. Okay, and I will be forcing this between two bounds. So there is an upper bound for this, and I will put the upper bound formula here and then the lower bound formula here. So my upper bound will be 2 times my auxiliary variable here, and for the initial value I will just put value 0 here, but these will turn into decision variables, so I will just color them green. And then the free transfers I have, surprisingly, these are also decision variables, because optimization will decide how many free transfers you will have each round. So this will turn into that. Only thing that's parameter here is the number of transfers. I will just use by values here. I will sum from v to all the way. So this is showing how many transfers I'm making, and I will just extend this formula. And then same for this, and this will be a plus minus 14 times 1 minus a itself. Okay, and so as you see, since a is currently 0, so the lower bound turns into minus 14. So we need to make sure that these values are always less than or equal to this, and these values are greater than or equal to this. And currently it is feasible, right? Because we are only using 1 transfer per round, and it doesn't matter what was the initial free transfers. But let's make sure that we are starting with 2 free transfers, just to make things a little bit more interesting for ourselves. So the one thing that I'm actually writing incorrectly is this f minus t is not this period's. This should be the previous period's free transfer, because how many free transfer I have right now is affecting this round, right? So these should be like this. So like for the third period, for example, I am using the free transfer from the previous round outcome. So this is how it should be, and as you see, this is being violated. So I'm just gonna change these initial values, but essentially for this solution right now, optimization should have been using like starting with the 2 free transfers. If I'm using only 1 transfer right now, then the next period I should have 2, and this should be 2, this should be 2, and all these are actually 1, meaning that there are some transfers that I haven't used, so that the upper bound and then the lower bound satisfies all these bounds. But optimization doesn't know this yet. So I will be adding these into as my decision variable. So I will do is I will click model, and I will come here, and I will hold control key in my keyboard so that it can be added to here. As you see, it added a comma and then this variable, and then I will choose all of these one by one. You can add them as a range too. So in here, as you see, they are colored already. So what I need to do, make sure is these auxiliary or artificial binary variables are actually binary variables. So I'm gonna edit. When I save it, you will say that it says binary. And another thing that we will use for the first time is, so these free transfers, right? So these should be integer. If in this drop down menu you will see int, meaning that it should be an integer. So these cannot take value 1.5, for example. They should be either 1, 2, 3, whatever. And we will be controlling that it won't exceed 2 using these constraints here. So I will add this. So when I save the model, you will see that it says integer here. So next is making sure that these 3 is less than or equal to their upper bound here. I will add it. And also again, these 3 should be greater than or equal to their lower bounds, and I will add this too. And as you see, I have binary variable, I have the integer variable, I have these 2 lower and upper bound relationships. Okay, I click save, and then you see, so the only missing piece is I want the next round to be exactly equal to this binary variable plus 1. Remember, that's why we were doing this. So I will just use this plus 1. So this is actually, let me put it here. So this is the resulting free transfer next round. Okay, and I will put 1 here and then all the way to here. Let me extend this, and this is, as you see, is binary plus 1. And so this is the last constraint I will be adding, hopefully, if I'm not missing anything. I want this free transfers to be exactly equal to these 3. Okay, I will be adding it, and then let's color them. So this is an outcome of what I'm doing here, so I will color them blue. So these bounds, they are being affected by the decisions too, and these FD, these are similarly metrics or outcomes, and similarly for this one. So the only thing parameter here is your initial free transfer. So currently I'm assuming it's 2. So we are ready. Remember that the initial solution was 207, and we were assuming that we can have only 1 transfers per round, limited. So when I solve this again, hopefully this objective will increase. So I will just put this value here as a value. So this was my initial solved value, right? So I will just zoom in here, and I will click solve, and I will fast forward this part, and we will talk about the new optimal solution. Okay, so we solved the problem, but as you may have noticed, my objective is 239. I mean, that's a massive jump, and there's a problem because obviously this shouldn't happen. And if you check the transfer counts, like, it's transferring 10 players the first round, so obviously something went wrong, and we know what it is. We didn't add the penalized transfers into our objective. Penalized transfer is how many transfers, how many hits you are taking for the transfers this round, and this will be based on how many transfers you have right now minus how many free transfer hits you had in the previous round. And so the one thing is, though, like, if you have a free transfer already, and if you don't use any free transfers for some reason, then this value will be negatives, and we don't want it. So so these instead of this, I will call this diff plus 1. So these are the differences, and then the penalized transfer will be a non-negative number, which is always greater than these. And so optimization, we will also add these as variables to our model, and I will color them again green because these are values that we will use. And finally here, this formula is actually not correct, so this should be how many transfers I'm making this round minus how many free transfer I had the previous round. So I will just copy this formula, and as you see, so I have actually plenty of, need to have plenty of penalized transfers. So one thing is I didn't add this to here, so I will just write 4 times this count, how many penalized transfers I'm having. So this will be 4 times this, and finally this will be 4 times how many. So under model here, I will say that, Okay, I will add actually these as my new decision variables. So I have a larger list now, and I will say this should be greater than or equal to these, and I will save it. So these will be forced to be integers by default because of the other relations we have, but you can also say that these penalized transfers should be integer numbers instead of continuous values. When I save it, you will see the whole relation, and I will click solve again, and we will talk about the new optimal. Okay, so we solved the problem based on the objective value. I think it is a very, since it's a very similar number, only almost 4 points more, a little bit more than that. I'm assuming that we solved it correctly, but let's see how many transfers we made. So in the first round, it actually performed 3 transfers, meaning that I had only 2 to begin with. I transferred 3 players, meaning that the next round I will have only 1. And as you see, since I have used all of my free transfers, my binary variable took value 0. This way, these bounds are forced. And as you see, since I had 2 and I transferred 3 players, my penalized transfer is 1, and I can see the effect on it. However, since I transferred 3 players, I think I have a better solution now. I will come here, and you see that it's complaining about a spill because we transferred 3 players that we didn't take that into account. So I will be adding a new row here so that it can be displayed correctly. As you see, I have a lineup and I have my bench players, and I'm selling 3 players, and these are the players I'm selling. So this increases my actually expected points for the first period a little bit, and I'm assuming it's also affecting these 2 as well. But for the remaining rounds, I'm only selling 1 player and I'm buying 1 player. In here, I'm selling my goalkeeper and I'm buying a new goalkeeper. In here, I'm selling the player I bought in the first round and then buying a new defender. And as you can see, I'm also using a captain in every round who is a playing player. That's it actually. Like, we solved the multi-period FPL problem with every constraints we can imagine. So for the rest, to be honest, you can hide these. You don't need to see them. You don't need them actually. So all you need to do now is changing your in the bank value and then your free transfer value, initial value, and then you also need to give them. You also need to give optimization your initial squad. Maybe I shouldn't hide that one actually particularly. Okay, so this is much better. So all you need to do is just putting 1 next to the player that you currently have, and then changing in the bank value and then your free transfer value. And then after that, I can even actually delete these. Maybe you can change your bench weight too if you want for the optimization. But this is pretty much it. I mean, you can come up with custom constraints like we talked in the first video. You can force a certain formation instead of, like here, I'm using 4-4-2 the first game week and then 3-5-2 for the second and third game week. But again, it's up to you. You can use different values, and then whatever you do, like, and actually let me add a new row here just in case. You will be able to see which players you need to use, you need to captain, you need to buy and sell here. Yeah, that's pretty much it. So the one thing I'm missing here, as you can see, is chips. So I don't have like free hit, wild card, or like bench boost, triple captain, these chips here. So those add an additional complexity to the model, and we already have lots of variables in the model anyway. And remember, under here, if you click model and options, we are using the default tolerance 5%. If I make this 1%, and I will just enable show optimization progress while solving, and if I click solve again, So after the problem is written, you will see a pop-up appearing here, and it will show you how the solution progress is going. And if I decrease this tolerance furthermore, then this will take a little bit, and Excel might not be the best tool to model these. But this week I noticed that there is an actually like Excel worksheet with all these things that we have talked about related with the free hit, related with the chips and then the free transfers, all these relations regarding the team counts and everything. Actually, someone made this into someone created a worksheet for this on Excel, so you can download it and you can start using it. So I will be giving a link under my own video here so that you can find that video and you can download the tool. I think from here now there are other stuff that you can do. You can model chips and other stuff, but things get a little bit complicated. So for that reason, I will be switching to Python for the rest of the series. I will talk about how to do optimization in Python, and hopefully it will be more useful in general. And as you can see here, when the optimization ran, you see the log file coming from the solver, and so it only took actually 4 seconds to solve the actual problem, but it took longer because we had to wait for problem generation and everything. So that's it. I will be saving this worksheet and I will be sharing a link in the video too, so you can download this exact worksheet. You can change these values based on the new values you can gather or you can generate by yourself, and then you will be able to use this worksheet. So the purpose in these videos were using Excel and an OpenSolver. So just to give you the taste that you can use optimization by yourself. You don't need to use any online tool or whatever, and you can do your own decision making. And as you see here, we have some flexibilities that some of the tools do not provide. For example, we are buying a player, we are selling the player, and then you can buy the same player again in the 3rd week. And you can also extend this to even further. Like you can, instead of I'm using 3 game weeks, but FPL review is giving you 8 game weeks of data. That problem is obviously really big. You are adding more decision variables, and things are getting a little bit more complicated. But we did it for the 3-period problem, so it is easier to extend it to 8 game weeks. That problem will take some time to solve. So what you can do is you can write the problem, you can set your tolerance or maybe time limit based on what you want, and then you click solve, and then you can just leave it open and it will solve the problem. So I think that's it for all I wanted to cover in this video. So if you have any questions, feel free to ask me about it in here, maybe on Twitter. I hope this was helpful to you, and I feel really excited about the possibility of you using these optimization tools that we have covered and using it in your decision making. So hopefully in the next videos I will be talking about Python and how to write this optimization problem we have mentioned in Python, because it will be easier to control and easier to use multiple objectives. For example, not only maximizing the following 3 game weeks, but we will talk about how to have a specific focus on a certain game week, and then it will help us with our decision making, especially for this game week, because the predictions for the following game weeks, like the future game weeks, tend to be less accurate. So based on what we know about the injuries and then the conditions, or maybe about what the coaches have been saying, it will be helpful us to give some importance to the next game week instead of the very far future game weeks. So that's all for now, and thank you very much for listening to me.